Okay, so I looked at testing different types of collisions. So car collisions unfortunately occur very often in everyday life, and we can't really control them. So understanding how the physics of collisions occurs can help us better understand how the people inside the vehicles are impacted. And hopefully with this understanding, we can engineer and create vehicles with better safety mechanisms. Um, I will be focusing on the investigate and analyze categories of the project. Investigating the physics behind car collisions will allow me to have a better understanding of the impacts they have on both the drivers and the vehicles involved, which is relevant to my future career as a physician, as it will allow me to have a better understanding as to how collisions impact the people inside the vehicle and help me make more informed and accurate decisions regarding their treatment. Socioculturally, this will hopefully encourage safer driving habits by making the general public more informed regarding collision severity, and also encourage new engineering and designs for vehicles that may help reduce trauma. So we will be looking at a head-on, T-bone, and two different types of one-way collisions, one where the heavier car is stationary, one where the lighter is stationary. So we collided or two different IOLabs in different orientations and use the force sensors that came with IOLab. Car 1 has no additive mass, while car 2 has an additive mass about 0.15 kilograms, and they're kept at a distance of 14 inches apart. These connects to our topics of momentum and impulse and force, because I'll be investigating collisions and taking measurements on velocity and acceleration to determine the changes that occur with momentum and impulse. And force, again, we have this equation for momentum, and we know that in both elastic and inelastic collisions, momentum is conserved. We also have Newton's second law, and we know that impulse is the change in momentum, and that the area under a force versus time graph is also the change in momentum, which is ultimately impulse. So looking at the data, this was the data produced for the head-on collision, and the left-hand set of graphs is for car 1, which was massless. This was what was produced for the T-bone. This was what was produced for the car 1 stationary one-way collision, and then this was produced for when car 2 was stationary. So we found for the head-on collision that car 1 had a greater magnitude of momentum change. For the T-bone, we found car 2 had a greater momentum change, and also the same for the one-way where car 1 was stationary, and also the one-way where car 2 was stationary. These are the values that Tracker produced or IOLab produced for uncertainty. So some potential limitations is that the force probe calibration could have been off with IOLab, also ensuring the car started from the same point each time. The human hand was the force that pushed the cars together, so this most likely varied from each trial. And also in trial 2, I noticed it appears as though the IOLab force sensor may have had some issues, because it doesn't show that car 2 received a force, but it does show that it had changes in velocity and position and acceleration. So for a head-on collision, car 1 experienced a greater magnitude of momentum change, which makes sense as we can visually see from the graph produced that car 1 experienced a greater force of impact than car 2. For a T-bone collision, while the data generated does say that car 2 experienced a greater impulse, we may attribute this to a malfunction in the force sensor, as we see visually from the graphs that car 1 experienced greater dips in position, velocity, and acceleration, which impact momentum ultimately. For both the one-way collisions, we see that visually the graphs produced are almost inverses or opposites of each other, which I found to be an interesting trend. And also for both the one-way collisions, car 2 did have a greater magnitude of momentum change. So it appears that for all the collision types except for the head-on, the heavier vehicle experienced a greater impulse, and this may suggest that mass plays a prominent role in how an object experiences a collision, which was kind of surprising to me, because I would kind of assume that if a smaller vehicle was getting rammed into by a heavier one, it would ultimately experience a greater change in momentum. So who knows if the results are attributed to maybe potentially changes in the force, the applied force, or IOLab differences. But hopefully, as a result of this, you'll be able to potentially design and implement more effective and crash safety mechanisms into our vehicles. Yep. Thank you.